Hello everybody, my name is Abe Nelson, and for my module today I'll be presenting on the impact of stratospheric aerosol injection on ozone depletion. Going over a brief outline, I'll give a very brief background of climate change, and then I'll talk about stratospheric aerosol injection, or SAI, what it is, and why it's being considered as a mitigation for climate change. Then I'll talk about ozone depletion and the effect that SAI could potentially have for ozone depletion. Finally, I'll wrap it up with a conclusion. Stratospheric ozone injection is a potential response to the problem of climate change, the increase in temperature caused by anthropogenic greenhouse gas emissions. The effects of climate change include rising sea levels, Arctic glacier melting, and increased risks of extreme weather and droughts. Temperatures have already risen by about 1.5 degrees, and they'll continue to rise unless serious action is taken. So, what is stratospheric ozone injection? SAI is a potential mitigation response to climate change, where aerosols are injected into the stratosphere. The aerosols can absorb or reflect the sunlight back into space, which has a net cooling effect on the Earth. This cooling can partially offset global warming and its consequences. So, now I'll discuss ozone depletion, and then I'll bridge the gap between SAI and potential ozone depletion. The ozone in the stratosphere absorbs UV radiation from the sun, protecting us from this harmful radiation. However, ozone can react with radical halogens in the stratosphere, which can deplete the layer. This phenomenon can be harmful because UV radiation can increase the risk of skin cancers like melanoma, as well as cataracts disease. So, what effect does SAI have on the ozone layer? The Chemical Sciences Laboratory conducted a study modeling the potential effects of different SAI strategies on ozone depletion. They found that in general, SAI would result in high ozone depletion at high latitudes, particularly in the southern hemisphere, while ozone depletion was more moderate near the mid-latitudes and the equator. While they found that the change in ozone could be partially controlled by the timing and method of aerosol injection, the general trend was that SAI would cause significant ozone depletion. The depletion of ozone is a complex modeling task with many factors, but the main causes of ozone depletion are increases in stratospheric radical halogen concentrations, as well as the increased warming in the stratosphere. The figure on the top shows the mechanism by which halogens destroy ozone, and the bottom figure shows how SAI could cause warming of the stratosphere. Now we'll go into a little bit more depth of these two main factors. First, aerosol surfaces can facilitate the generation of reactive halogens. Halogens are mainly present in the stratosphere as unreactive reservoir species, like chlorine nitrate. However, the surfaces of aerosols can serve as a medium for these unreactive forms to be converted into reactive species. These reactive halogens are very potent ozone destroyers. Each molecule of chlorine, for example, can destroy tens of thousands of molecules of ozone. On the right side of the screen, we can see the mechanism by which chlorine destroys ozone, and this catalytic cycle can be devastating to the ozone layer that protects us from UV radiation. The second main factor that contributes is the increase in stratospheric temperature. In addition to reflecting, sulfate aerosols also absorb solar radiation. So despite cooling the troposphere where we live, it can cause heating in the stratosphere. The effects here are a little bit less straightforward, but they still lead to a net ozone depletion in the stratosphere. First, heating strengthens horizontal transport, which can result in more ozone production at the mid-latitudes, but strengthening the polar vortex, which causes severe ozone depletion in the Arctic. I didn't have time in this 5-minute presentation to explain the details of this mechanism, but I'd be happy to answer any questions about them in the Excel spreadsheet. So, in summary, stratospheric aerosol injection could cause ozone depletion by generating halogen radicals and decreasing stratospheric temperature, causing issues like melanoma and cataracts risks. However, the extent and nature of ozone depletion depends largely on the timing and method of injection. That's all I have for the presentation today, but thank you for watching, and I look forward to taking everybody's questions.